cubed of 2t. And the very first recommendation that I have is whenever you have a trig function, typically the notation is to write the power right on the trig function. That's not really what that power means. What that power means is that we have tangent of 2t, the entire expression is raised to the third power. So, in my opinion, I think it's a good idea to rewrite that trig function so that it looks like we're taking tangent of 2t and wrapping it in a big bear hug with those parentheses raised to the third power. Okay, so our goal is going to be to find the derivative of h of t. And so what I see here, now that I've rewritten this, is that I have nested functions. In fact, I've got a couple of layers of nested functions, but I'm going to start with my outsidemost function. And my outside function, in this case, is x to the third, or t to the third. It doesn't really matter what variable I choose to call that. But my outside function is stuff raised to the third. And my inside function is tangent of 2t. So notice that what I'm doing here is I'm peeling off the outside layer. Alright, so my outside function is x cubed, my inside function is tangent of 2t. So when I take my derivatives, I'm going to need both of these derivatives. My derivative of x cubed is 3x squared. And my derivative of tangent of 2t, well, when I look at this, even within this function, tangent of 2t, I see something fancy inside the parentheses. So I actually have a second chain rule here. So looking at the derivative of tangent of 2t, well, looking at that function, I've got an inside and an outside. My outside is tangent of x, and my inside is 2t. Alright, so to take the derivative of tangent of 2t, I need to know about my derivative of tangent x. What is the derivative of tangent of x? Yeah, secant squared x. And my derivative of 2t is going to be just 2. Okay. So let's see here. For our inside function of tangent of 2t, we're going to take derivative of the outside, keeping the inside the same. So we've got secant squared of, keep the inside the same, so secant squared of our inside, which is 2t. So secant squared of 2t. Derivative of the outside, keeping the inside the same, times the derivative of the inside, which is 2. All right. Are there any questions on our derivative of tangent of 2t? Okay. Derivative of the outside, secant squared, keeping the inside the same, 2t, times the derivative of the inside, which is 2. Okay, so now let's go back up to our original function. Calculating h prime of t, our inside function is tangent of 2t, our outside function is x cubed. Derivative of the outside, keeping the inside the same, is 3x, well my x is my inside, so 3 times tangent of 2t, whole thing squared. Derivative of the outside, keeping the inside the same, times the derivative of the inside. Now our inside function was tangent of 2t. Its derivative is secant squared 2t times 2. Final answer. All right, so let's go back to the beginning of this one here. So I had somebody tell me a very cheesy statement, and I'm about to tell you this cheesy statement. And here it is. So the chain rule is like an onion. If you want to work with an onion, You have to peel it layer by layer, starting at the outside, and sometimes it makes you cry. All right, so here we had our outside function, which was x cubed. Our inside function was tangent of 2t. We took the derivative of the outside, keeping the inside the same, times the derivative of the inside. Well, our inside function was tangent of 2t, and that one we had to use a chain rule on as well. Okay, so our inside there was 2t, our outside was tangent x. Derivative of the outside, keeping the inside the same, times derivative of the inside. Okay, any questions or comments about our h prime of t? Okay. So then our last example was one where we had a fraction, and that fraction, the entire fraction was raised to a power. And so what I see here is sort of the big picture of what type of function we have is I see blob of stuff, and that entire blob is bear hugged with a set of parentheses and raised to the second power. So what I see going on here is nested functions. And so I've got my inside and my outside function. My inside function is 1 plus 2x minus x squared over 3 minus 4x cubed. And my outside function is stuff squared. So my outside function is x squared. All right, now we're going to need the derivative of both these pieces. The derivative of the outside function is easy. Derivative of x squared is 2x. But my inside function is going to take a little bit more work. What rule am I going to need to apply for my inside function? Quotient. Yeah, this is the quotient rule. I've got two functions and they're being divided. So for my derivative, I've got low 3 minus 4x cubed d high. So the derivative of my top part, I've got 2 minus 2x. So we've got low d high minus high 1 plus 2x minus x squared. So low d high minus high d low. So the derivative of my bottom, the derivative of 3 is 0. And then we've got minus 12x squared. So low d high minus high d low, draw the line, and square below. So square the 3 minus 4x cubed. Okay, so these are the derivatives of our outside and our inside. Are there any questions about those? Okay, so now that we've done that scratch work off to the side, our y prime or our dy dx, either way, either notation works. Derivative of the outside, keeping the inside the same. So my derivative of my outside is 2x. So everywhere I see an x in my derivative of my outside function, I'm going to replace that with my inside function. So I've got 2 times 1 plus 2x minus x squared over 3 minus 4x cubed. So derivative of the outside, keeping the inside the same, times the derivative of the inside, which is this whole shebang right here. So we've got 3 minus 4x cubed times 2 minus 2x minus 1 plus 2x minus x squared times negative 12x squared, all divided by 3 minus 4x cubed squared and bracket. And this right here is a legitimate final answer. All right. Are there any questions about calculating that derivative?
Anything else you would want us to simplify at all?
No. In fact, on a test, I will say, do not simplify, and if you do simplify, you simplify at your own risk. So, but that being said, it is very important that you make valid use of parentheses. So for example, when we have low, d high, make sure your entire low function is inside parentheses. Your entire derivative of the top is inside parentheses, minus high is in parentheses, and d low is in parentheses. So you make sure you have legitimate use of parentheses. That could be a problem. Okay, other questions or comments?